Okay, so I just did a quick little base coat paint job with some leftover Chevy orange just to get the outside surfaces mostly coated so that they didn't start to cause any surface rust, because I didn't want to have to make any more dust cleaning it off later. So I just did a light surface coat, and that'll keep it mostly well protected until it's ready to do an actual engine paint job. So the last step we did before that was take out the cam bearings, and I just wiped these cylinders down. Now we're going to hone the cylinders before we put the new cam bearings back in. Alright, so how to hone a cylinder. Basically, you're gonna measure and determine what your bore diameter is. So these are 4-inch bores. So I need a hone that fits into a 4-inch bore. So what I picked up for this one, just a dingleberry hone, flex hone. This one is 3 3/4 inch to 4 1/8 of an inch. So that is the nice part about flex hones, is that they have a decent range. So you just get your flex hone and your cylinders all cleaned up. Lubricate the cylinders and lubricate the hone. Just conventional engine oil is good enough for it. You just want some oil on it. These can be drenched if you want. It doesn't really make a difference, but it'll help reduce heat, and it'll help the tool cut faster and last longer. So basically you just lubricate the cylinders, lubricate the hone a bit, and you're going to want to run on a drill at a lower RPM. This flex hone is good from I think it was 60 RPM to 1200 RPM. So I just set up my drill here so that it has about 600 RPM. I do have a lower setting even for this that's like 130 RPM, and either one is fine. They'll both pretty much cut the same, just the faster RPM is going to increase the heat and it's going to cut faster. So it's definitely important to have oil and lubrication if you're going to be cutting faster at a faster speed, but you never want to go over what the manufacturer recommends for the speed setting on the hone. Just demonstrate it quickly here. So you just need a drill, the hone, some lubrication, and you never start the hone in the cylinder. You always start it outside the cylinder, and make sure that you're square to the cylinder. You don't want to go in on an angle. So you want to start outside of the cylinder, get it up to speed, and plunge in and out without stopping. Now the goal here is to get a good crosshatch pattern with about a 45, I think it's 45 to a 60-degree angle on your cylinder walls for the crosshatch pattern. And to achieve that angle, you basically want to be running the drill constantly so that you're staying at a consistent speed and moving in and out of the bore at a steady pace of 1 stroke per second. So 1, 2, 1, 2, 1, 2. That's all you want to do. And I'll wipe this cylinder here. Now you can see that's got a nice crosshatch in there. You can see the lines coming this way, and they meet at about a 45, maybe 50-degree angle. And that's exactly what you want all the way through your cylinder, to get a nice crosshatch pattern. And the crosshatch's purpose is to allow oil to stick to the cylinder wall. If you're too steep of an angle, like this, if it's coming up too steep, you're going in and out too fast, then you're going to have not enough oil sticking to your cylinder wall, and that's gonna cause increased temperatures in that cylinder and increased wear. And if your angle is not steep enough, if it looks just like swirly rings going around and there's no crosshatch, then you're gonna have too much oil sitting on the cylinder walls in those ridges, and that's gonna allow oil to blow by and burnt oil, and that's gonna be a whole other set of problems for you. So you want to keep it within the range, 45 to 60 degrees crosshatch. Do that to all the cylinders. And that's how you use a flex hone. Alright, so your finished hone job is not going to be very shiny. It's going to be somewhat opaque, but you can see the cross hatches there. Looks like spider webbing. That is exactly what you want on the inside of your cylinders once you're done honing. That's all there is to it. Okay, so setting up the dial bore indicator here to read, and this is specifically for a 4-inch bore for mine, but it's the same procedure depending on your own specific bore size. So this one, I have a bore of 4 inches that I'm measuring, right? So I set this vernier to 4 inches. You can do this with a micrometer or a vernier, as long as you can lock it down. So I have that locked in at 4 inches. Next step is you want to take your dial bore indicator and you want to put the extension in the appropriate length. So this is the 4-inch extension to make this total length at the bottom here 4 inches. And we're just gonna have this next step is when you lock in your dial indicator with this little sleeve here, just tightening this little bolt to tighten the sleeve. What I like to do is, you see that this is a 10 thousandths dial indicator here. So you see that smaller circle? That smaller circle has 3 numbers on it. It's got a 0, a 1, and a 2. So that just counts the revolutions, basically. I think it's based on per 10 revolutions or something like that for each one. Anyways, that's not the important part. The important part is that you want to set your dial bore indicator in so that when you, I'm pulling up on this here to make the dial move, but when you have the dial indicator set in here, push down all the way, and you lock this little screw here. I just like to set it up so that the little dial is lined up with that 0 there. So I know it's hard to see on camera, but as long as you get it lined up with that 0 there, then you're fine. And you use that to count your revolutions, and that'll come in handy in a second here. But next step is you just take that after you lock it in. You take your vernier and you put it on the bottom end here, and you're just gonna rock it back and forth along the vernier until you get to the point where the needle turns around. So you can see it's right about there where the needle turns around, and that is how you know that is where you're gonna set your 0 on the dial indicator to. So just loosen off the lock screw, you turn the cap. I do it multiple times just to make sure. And I will line that up. About there is where it's lined up to the maximum travel on the dial indicator, is right where the 0 is here. So then you just lock in your little thimble here, thimble screw. And that way, when your dial indicator travels around and reaches that 0, that's your 4-inch mark. That is where you have set your dial indicator to match what your vernier was, or your micrometer. So when I get to that point, I now see on the little hand, the little dial, that it's moving, right? So when this gets to that 0, you can see that that little dial has moved about 3 of these little notches on the smaller circle. About 3 of these here is where it gets to the 0 like that there. And that is how you would count when you are looking down into a hole. So for example, on this small block here, we would stick this down inside the bore, and you would rock it back and forth until we get that dial to reach. On the small circle, it's reached the 3rd notch, and I know it's hard to see, but it's reached the 3rd notch on the dial, which means when it's at that 0 now, that's 4 inches. So anything you move past that, and then where it turns around, that is what your bore diameter is. So this one is 4, where I'm measuring now, 4.0012 by the looks of it through the camera. And what I would do is measure the taper of the bore. So I would measure in 3 sections, one at the bottom, one at the middle, one at the top, and I would do that in 3 directions. So if I did it in this direction, the vertical direction, and then I'd turn it a third of a turn, and then I would turn it a third of a turn, and do that up and down each cylinder. So I would have 9 measurements for each cylinder. It'd be 3 at this height, 3 in the middle, and 3 here, with 3 in each of the clock directions. So that would give you 9 measurements for each cylinder, which will tell you pretty accurately how your cylinder has tapered, if there is any taper, and also the out of round of the cylinder at the bottom, middle, and at the top. And that is how you will determine if you do need to get your engine machined, or if you are within specs for the allowable taper and out of round for each bore. So I'll walk you through it one more time just to make sure everyone knows what's going on. You take your vernier caliper or your dial indicator, you set it to the diameter that you need. So I need 4-inch bores is what I'm measuring. I want to see how much over or out around these bores are, right? So 4 inches, you get your dial indicator set in, and you want to have it so that the little dial here, oops, is just sitting on that 0, and that'll just help us later on when we need to make sure that we're not counting too soon into the travel. So set that, get your appropriate anvil end here for the extension rod. You slide it in between the jaws on your micrometer or your vernier, rocking it back and forth until you have reached the highest point of travel on your dial indicator, and where that'll be when the needle starts to turn back and forth. So when the needle starts to reach where that 0 is and rotate, it'll go up and it'll come down. That's where you set your 0 to, and then you count the little dashes on the small gauge, and you remember it was about 3 that we had on the 0, right? So that would be 4 inches right there. So when we go back over to the block, we know we don't bother counting any turns past 0 until we've reached that third little dash on the small dial, and then from that 0 is where we count up to get those 12 thousandths of an inch over 4 inches. So it's 4.0012 inches, and that is how we measured with a dial bore indicator.